Hello, everybody. My name is Brian Berger, and I'm the editor-in-chief of Space News, and it's my privilege to thank you all for being with us here today. We have two great guests who are eager to talk about an important topic, namely NOAA's future satellite architecture. But before we get into that, I'm pleased to thank our sponsor for today's webinar, Maxar Technologies. Maxar support helps ensure that we can continue to bring events like this to you on a regular basis. Maxar provided a short video that they'd like to share with you, and I'm pleased to present that to you now.
For 2 decades, government and commercial organizations have relied on Maxar satellite imagery to map, monitor, and provide Earth intelligence at a global scale. Today, Maxar operates the world's most sophisticated commercial imaging constellation. But to help customers keep pace with rapid change around the world, we are excited to introduce Worldview Legion, our next-generation, high-resolution Earth imaging constellation. Designed and built in-house, Worldview Legion will fly in both sun-synchronous and mid-inclination orbits to dramatically increase Maxar's revisit over the most rapidly changing regions on Earth. It will triple our high-resolution 30-centimeter coverage and overall imaging capacity, allowing Maxar to capture many areas up to 15 times in a single day. This enables Maxar to better support applications that require current and accurate Earth intelligence, with frequent updates on changing ground conditions for enhanced monitoring, foundational and national security and military operations, accurate mapping, a key component on the road to autonomous vehicle technology, and expedited access to post-event coverage, critical in the wake of natural disasters. With Worldview Legion, Maxar is shaping the future of what's possible, changing the way we detect, understand, and address change. The next era in Earth intelligence begins at launch.
All right, well, thanks to Maxar for providing that video, and thanks for sponsoring today's webinar. Before I turn you over to our moderator for the day, I just wanted to get a couple housekeeping notes out of the way. These are important ones. They concern audience participation, audience Q&A. I asked that everybody use the Q&A function at the bottom of your screen instead of the chat. If you use the Q&A function and keep your questions succinct, it allows us to sort through them and get to them as many as we can. So yeah, please make sure you use that. The other thing I'd like to bring to your attention is I believe you have some control over what you see on your screen by using the gallery view / speaker view button. It should be at the top of your screen. So if you don't like the view you're getting, if you want to be able to see everybody at once, that can give you some control over what you see. All right, so now it's time for me to turn today's webinar over to Debra Werner, longtime Space News correspondent, who is joining us this morning from San Francisco. Debra?
Hello, everyone. Thank you for joining us for this Space News webinar with the two leaders of the National Oceanic and Atmospheric Administration's National Environmental Satellite Data and Information Service, better known as NESDIS. Today, we'll be discussing how NESDIS gathers, analyzes, and shares global environmental data with a wide range of users in the United States and around the world. While timely and accurate weather and climate data has always been important, it feels particularly vital in this period of climate change. Recent NOAA reports have pointed out that 2019 was the second hottest year on record after 2016. A record-breaking Atlantic hurricane season is underway, and nearly a quarter of the United States is experiencing moderate to extreme drought conditions. After this brief NOAA video, I'll introduce our guests. Today we have the pleasure of speaking with Dr. Stephen Volz, Assistant Administrator for NOAA's Satellite and Information Service, and Vanessa Griffin, Director of System Architecture and Advanced Planning at NOAA NESDIS. Both of them have decades of experience. Steve previously served as Associate Administrator for Flight Programs in NASA's Earth Science Division, and Vanessa previously managed development of the GOESR satellite ground infrastructure, one of NOAA's most extensive IT development projects. Welcome, Steve and Vanessa. We're delighted to have you with us today to discuss NOAA's plans for the next generation of environmental satellites. I should have mentioned that the current generation, often known as GOESR and JPSS, GOESR stands for the Geostationary Operational Environmental Satellite R series, and JPSS is the Joint Polar Satellite System. Welcome, Steve and Vanessa.
Well, thank you, Debra, and thank you for explaining those acronyms. I know we have a lot of them, and it takes a while for us to remember what they are sometimes as well. Just a brief statement up front. I'd just like to acknowledge up front, as before we get into the details of satellites and data and information, is that sort of acknowledge the very different environment we're working in today, both due to COVID pandemic and to the national expressions that we're seeing, sort of outrage of unequal treatment of many in our community. These realities are really affecting virtually every aspect of life in ways large and small, and us as in an organization as well. It's influencing how we go about our daily tasks as scientists and engineers and managers in NESDIS and in NOAA, how we collaborate with our government and industry partners, and with how we interact with our academic, NGOs, and media colleagues and the commercial sector as well. I think most important, though, it's affecting how we treat each other as individuals and as organizations, and how we look for the health and the well-being of everybody in our community. And that's not just personal, but it's also organizational and institutional. And I think this is an opportunity, but it's most certainly a clarion call, I think, to evaluate all the aspects of how we act and who we are and how we work together. And I understand this may seem like an odd way to begin talking about satellite observing systems and the next generation technology investments, but I really believe that we must apply our approach of inclusion and collaboration not just to how we work with each other, but how we work as organizations and institutions. As we are now defining, designing, and deploying systems, we're going to do that in a very different way than we have in the past, and that's part of what our conversation today is going to be about, is how we're doing that differently. We're reaching out to the aerospace and the remote sensing community in a broad way to listen and to learn from the experts who have experience in industry, other agencies, and academia, as we consider how best to refresh our flight systems. We already did this with our NOAA Satellite Architecture Study, which Vanessa will talk about. We're doing this now through our broad agency announcement studies, which are ongoing and will continue. We're reaching out to the users of the data and information in a different way through our user engagement workshops, asking the end users how they operate in their field, not just how they're using our data, so that we understand their challenges and how they expect the environment to change over the next 10 years. The world in 2030 will look different than it does now, and we need to be prepared for that. I see NOAA as sort of the service innovator, but it's our partners who are really the technology innovators. We work on delivering better and tailored products, but it's the technologies and the instruments and spacecraft, our industry primarily, and our customers are the ones who know about how they need to change their environment and their interactions with the community. So with us as the service hub and the technologists on the industry side and the users and the user and the engagement side, I think we have a really powerful organization working together, and that's what I hope you'll hear about more today. Thanks, Debra. So over to you again.
That's great. So Steve, as I understand it, GOESR and JPSS should continue to provide weather and climate data into the 2030s. So if that's the case, why are you already looking beyond those constellations?
So I'll give two reasons for that. First is, as most of you are familiar with the aerospace industry, it takes a while. It takes 10 years to design and deploy a new and capable system, especially if you're starting from something with is already high performance, like we have for JPSS and GOESR. For our geostationary satellites in particular, we see a replenishment need for that constellation around 2030. So we're only 10 years away from having to have a new system deployed. Second, I would say we have capable systems in our low Earth orbit or polar constellations such as the JPSS series, with 3 more in the pipeline. But we also see an opportunity based on the rapid expansion in capabilities and affordability of the small satellite revolution that really allows us to deploy satellites that complement JPSS and our European partnership, the meteorological, the MEDOP series, to demonstrate new missions, new measurements, and new techniques. And we see that these can then complement what JPSS has, but also examining what we can use to replace those satellites in 15 years so that we don't need to necessarily build these large, complex systems if we can do it in a different way. And we also recognize that right now our legacy systems of the DMSP, the Defense Meteorological Satellite Program, and our last generation polar satellites from NOAA are going to go offline in the next 5 years. We have, I think, 7 satellites which we expect to retire in 5 years. So these create, you might call them data gaps, but they create an opportunity then to deploy something new. And that's why we're working now to define what we will be deploying in the mid-decade and for LEO, low Earth orbit, and the end of the decade for geostationary.
Thank you. So in the past, you've relied primarily, as you just mentioned, on these very large, very capable satellites with multiple instruments designed to gather data, and many of them last far more than a decade. What's made you reconsider that model, if you have?
We have, and that approach has been successful, as you said, for generations. And our own video just showed from 1960 and beyond and on. But the generational approach really envisions a block upgrade, if you will, every generation, 20 to 30 years. And that does not adapt well to new technologies, new opportunities as they come out. So the small sat revolution, the research instrument developments and demonstrations that are being shown right now, it would take us a long time in the old style to build those into highly capable satellites. And also the old approach creates very capable, very expensive systems. And we see them as not being ready for infusion of new measurements on a regular basis. The Earth observing environment is evolving much faster than that generational approach would support. And we want our systems to bring on new capabilities faster and to be more adept to adapt it within a cycle in some areas, to be agile, in other words, so that we can enhance as we evolve, as we deliver services, and not just wait for the next block upgrade, which might be a decade or 2 away.
When you talk about advancing and adapting your services, how important is the ground infrastructure and the IT element to all of this?
It's really absolutely essential because when you design on a generational scale, you can upgrade the ground system the same time you do the satellite. So you marry a new ground system with a new satellite system, and they're designed from the start, and then you deploy those. If you're infusing measurements one at a time or a satellite at a time into an existing architecture, you want to have a ground system that is able to ingest those data and those new observations seamlessly into the existing system. So we have already started to figure out and design ways to bring in those operationally bring in new data. We have what we call a secure ingest program, operational secure ingest, which we brought into service operation this spring, which allows us to ingest data securely with effectively zero latency from our international and interagency partners. And that allows us to deliver improvements to our data and products with new data sets without the long time to develop a new ground system. It puts the burden on software and on product analysis and assimilation, not on hardware development. We are evaluating right now the correct way to evolve our IT systems and considering and planning moving major portions of our on-premises IT systems to cloud-based approaches. Not everything. Some don't. Command and control, for example, will not move right away, but product development and data dissemination likely will. We see the scalability and speed of cloud operations as a clear service enhancement in many areas. And we already, for example, are making available GOESR data and partner data from our Japan Meteorological Agency, JMA, the Himawari satellite, available through the cloud with almost no latency. This would have been much more difficult to do years ago when we had to develop a whole new ground system. We have many more data streams of the similar in works. And finally, I would say NOAA has the owner of sort of the largest climate and environmental data archives in the world, but it's been challenging for us in the past to get access to those archives, to provide that data so people can use it easily. both for our internal operating users, Weather Service and the Ocean Service, but also to the global community. With advances in IT systems and cloud technology and AI and machine learning have made it possible and profitable to accelerate the delivery of those data to the broadest community possible. And we're revising and restructuring our IT systems to make that possible. Our objective is that within approximately 10 years or thereabouts, to have all NESDIS data available for rapid dissemination and real-time processing in a common cloud framework to make those data available to all of our users in the world.
So all of these changes, I imagine the opportunities that I've heard you mention in the past are, I see things like multi-temporal, multi-spatial measurements, more observations from all around the atmosphere. Let me just ask you about the opportunities that you see through this change.
The opportunities are really to provide a much richer information content to our users than we have in the past. We primarily in the past had focused on maximizing utilization of a NOAA asset. And our new paradigm is maximizing information service delivery using all available assets. In the last 20 years, the world has exploded with availability of on-orbit satellites. And we've created what we call our Data Source Agnostic Common Services Program, which we call DACS, which is focused upon bringing in data from all viable and productive data sources to integrate into a seamless output of information. So in a much richer real-time observational picture of the planet. And we include in that stream NOAA, NASA, EUMETSAT, our partner, Copernicus program, and other JMA and JAXA, a lot of acronyms, but international agencies, EO agencies from around the world. This data will lead to a much richer data set into our numerical weather forecast products, to operational on-station and on-screen for operational weather forecasters in our weather forecast offices, to our fisheries and coastal services for all the kind of real-time planning for executing their functions, but also to the weather and environmental enterprise writ large so that they have access to these data sets and create an entire, much broader range of applications and services beyond what NOAA is chartered to do, but we can now have ready access to the data. Our big data project that we've set up within NOAA is actually focused right now on making data dissemination of 5 new petabytes of data available. We're defining now how to make that happen. And I know you didn't mention it, but there are challenges to this. As we recognize is that pushing data to users does not always mean the data can be used, because the users have capacity challenges as well. So we need to manage at our end the torrent of data that's coming out. So not just to shove more stuff to the users, but to send the right stuff in the right format. And that's where the user engagement feedback is key, and the community feedback on what the problems are so that we can filter and tailor the information content in a much more productive way. So, the weather forecast officer is stretched too thin already, and we need to make sure that we manage the information flow and not just maximize the data flow. And that's really the challenge that we have, that it's not NESDIS's challenge alone, it's the entire community requires input from all.
Got it, yes. Steve, there was a chart, a graphic that you showed at the American Meteorological Society meeting in January. Can we put that on the screen? It talks about the changes in the marketplace. And it just shows how NOAA used to be a bigger segment of this market. I show that because I wanted to ask you about partnerships and whether those are becoming increasingly important.
Absolutely, and if you look at this graphic, you have to really squint to see the NOAA blue there anywhere. It was 15% back in 1980, and it's less than 2% in 2019 on the number of satellites. And as we mentioned at the AMS conference, number is not quality, and ours are maybe higher resolution than some, but certainly it would be ridiculous to ignore the value of all these other services. So I'll quote a good friend of mine and a global leader in Earth observations, Dr. Mike Freilich, who unfortunately passed away just last month, who used to say that No single agency, no single nation, and no single continent can observe and understand the Earth and its systems in the way that needs to be done to understand and prepare for climate change. And all of our approaches, from partnering on mission development, whether it's with Taiwan and ESA, for shared rides with NASA and the Air Force, onboarding data through our DAX program, all recognize the value of all these many contributors. We cannot meet our mission, our NOAA mission, with only NOAA satellites. We require our partners. And I don't see it as a question of, is it either or? Is it NOAA or commercial sector, NOAA or NASA? I see it's really an and question. It's NOAA and whether all those multiple sources of data. Our challenge is to prioritize based on impact, based on value to the end user, not just cost of the data, but value to the end user, and to integrate and as seamlessly as we can all of the inputs. And this year, as Vanessa will talk to in a minute, we just released a commercial data purchase for the first time in NOAA's history for satellite data, RFP, that's on the street right now. Recognizing the addition of those commercial data sources can complement and augment our system. And I expect those to be a significant part of our observing system delivery in the future.
That's great, thank you. Vanessa, I wanted to bring you into the conversation because you are helping define the next generation architecture or getting the inputs to do so. How are you doing that?
So going back, let's start with the NSOSA study itself that Steve talked about, which was the NOAA Satellite Observing System Architecture Study. It was a multi-year study where we looked at possible architectures of how we could meet our requirements in the future after the GOESR and JPSS timeframes. In those cases, you know, we looked at hundreds of different architectures of different approaches of small sets, you know, CubeSats, large sets, you know, other ways, other business models. And we evaluated those architectures for their value as well as their cost. And we tried to determine which of those hundreds of architectures, you know, were sort of in the sweet spot, if you will, in the knee of the curve between the value they offered versus the cost of what we thought it would take to implement those architectures. And in some cases, just to give you an idea of how we were talking about value, Steve has mentioned some of those values today. Obviously, we want to make the same, we want to provide continuity of the observations that we make today from our current platforms. People are using those, obviously, in real world situations and weather forecasting and ocean studies. And so we want to continue to make those measurements. But at the same time, we want to look at ways to make new measurements, provide new observations that perhaps we couldn't make before. Technologies have enabled us to make these measurements, or perhaps other, you know, there's just the ability to do more things. So we wanted to look at that as a value. We also looked at the flexibility of how you implement the architecture. Steve talked about, you know, it taking a long time to develop these large government satellite mission systems. And so we looked at flexibility. How would we gain more flexibility in, you know, the time to target, if you will, of how fast we could develop a new instrument, put it on a spacecraft, launch it, and get it into space for observational purposes. Look at how we could be flexible in responding to changes in technology or instrument needs. Right now, as he talked about, there were generational satellites, so you didn't see major changes for generations. And so we looked at that as a real value. So we came up with these candidate architectures in what we call the efficient frontier. But we didn't stop there. This wasn't an exercise of doing things and putting it on the shelf. So now we looked at how would we actually implement that architecture? How would we start actually doing that? And I would say that while, you know, we had a wonderful team, a very involved team, a lot of people involved in looking at NSOSA, we wanted to widen the scope, if we will, wanted to widen the funnel of ideas and concepts and instruments. So we saw the need to go out to industry and academia, government labs, and get their best ideas as well, to complement ours, in some cases to validate our own models, to validate our own assumptions about what was feasible, what could be done over the next 20 to 30 years. And so we issued what we're calling broad agency announcement studies. These are 6-month studies to look at mission, instrument, constellation concepts, both in LEO as well as in GEO for the next generation GEO satellites, looking at space weather satellites and space weather observations that are needed, looking at different orbits. And so we've had 31 of these contracts now that have been awarded. Now, like I say, they're 6-month contracts. About half of those were awarded looking at LEO applications, low Earth orbit, and about half are looking at geostationary or space weather, what we're calling extended orbits. We call it GeoExo for geostationary and extended orbits. In this case, of course, extended meaning either highly elliptical orbits around the Earth, as well as orbit points at the Lagrangian points, 1 and 2, and the things that we're doing there. So we have started now looking at how we implement those, validating our concepts, looking at doing more analysis, and of course, widening the scope of people and partners that we are participating in and doing this architecture effort.
Great, okay. And what happens next? We've got a lot of questions, so I'm gonna try to leave time for those. But where do you go from the studies that you've got out?
That's a process that will be evolving as we go, but basically right now we're looking at, as Steve mentioned, we need to launch a replacement mission for the GOESR series as early as 2030. So we need to get started very quickly on developing the instrument and mission concepts for such a mission. So these pre-phase 8 studies that we awarded this year, the analysis from those studies will feed the analysis and concept development in phase A of the next mission. So the GEO program will take this data and use it to decide how best to implement these measurements, how best to observe these measurements. And I will say that we're looking, as Steve talked about, we're looking at what I call a hybrid architecture. So we're looking at a combination of satellites that the government will develop, fly, and operate, looking at commercial options of actually acquiring data that commercial companies are acquiring and buying that data where it's feasible, where it meets NOAA's mission and fits in well with our mission capabilities, and depending on, talking and collaborating with our partners, both our international partners and our interagency partners, to acquire data. So it's a hybrid approach. And even if you look at hybrid, even on the flight side, it's still a hybrid sort of combination between large satellites and smaller satellites, especially in LEO. We're really going to take advantage of this wave of innovation that's been occurring in the small satellite, CubeSat, instrument development arena in low Earth orbit. And we're going to leverage that to the maximum extent we can to develop our next set of platforms. We're doing what we call disaggregation and proliferation of these small sat missions or the low Earth orbit missions. And that allows us to take instruments that we're currently flying on large satellites where we had multi-instrument, multi-sensor kind of missions, take those instruments that require high availability and would really benefit, where NOAA would really benefit from additional revisit time, shorter revisit times, more refreshes, and put those on smaller satellites so we can have more satellites operating in different orbits and looking at how we could increase the revisit time, decrease the latency, make the data more useful for NOAA mission.
Great. When we say weather, we usually mean terrestrial weather. Is space weather part of this?
Absolutely. It was part of NSOSA from the beginning, looking at space weather observations that NOAA needs to meet our mission. And we're actually treating that, almost separately now from GEO and LEO. We're looking at space weather observations as a thing we need to make our own. So some of the studies, at least 2 of the studies we're doing this year, are looking at space weather opportunities, including how you would architect a space weather observational system, as well as looking at one particular measurement, looking at the auroral imagery, either in geo orbit or in a tundra orbit, which is a highly elliptical orbit. So we're looking at that as well.
Got it. Here's a question from the audience. Somebody asked whether NOAA is planning to use the Small Business Innovation Research Program to advance weather satellite observation technologies.
Steve, I can take that one, and you
Yeah, go ahead.
comment as well. We are actually looking at how we have new other transactional authority that was provided to us from Congress, and we're looking at how we use that and how we can use that to, again, speed time to target, in some case get contracts or get procurements with non-traditional companies that aren't used to doing U.S. government contracts. So we definitely will be using our OTA authority. We'll be leveraging that at every opportunity that we can, and we're just starting to look at that now more on the ground side, but we'll be looking at it as well as the flight hardware procurement side as well.
Yeah, and I was going to add to Vanessa's point on the space side. The space side is a little more challenging because of the rate, the cost, and the duration of the missions. But half of our investments go into our ground systems, and so that's definitely a ripe area for innovation. And as Vanessa mentioned, we are working to see where and how that can be applied for our ground investments.
Somebody else asks regarding the Soundersat studies, whether people who are not currently participating will be able to get involved before the procurement.
I would say absolutely. Again, the study contracts that we awarded, we're looking at certain areas where we had a lot of questions, and we wanted to sort of get some advice or get some engineering analysis from these different companies. So if you look at like LEO Soundersat, for instance, which was about half of our studies were in the LEO Soundersat, about a quarter of those are looking at actual instrument development. So they're candidate instruments that government labs and academia already have either engineering units or have designs, then we're looking at how we might leverage that and use that, and what the, again, what the constraints are of using, a smaller instrument or a miniaturized instrument. About half the studies for the LEO side are looking at mission concepts. So how would you take an IR sounder, a microwave sounder, and a radio occultation sounder and put them on a satellite? What size satellite would you need? What would be your power, weight, and requirements? How would you fly that? How would you operate that? So they're looking sort of at the mission level concepts. And then several of them are also looking at unique business models and acquisition models. So are there opportunities for, data as a service? Are there opportunities for commercial hosting? So another thing, so some of the more innovative things. And they're also looking at constellation construction. If we're going to do a constellation in low Earth orbit to do the sounding missions, how would you structure that? What orbits would you need? How many satellites would you need per orbit to meet the objective requirements that we put into the BAAs themselves? So, but as far as getting on board later, yes, as we go into phase A, and we will go into phase A for LEO Soundersat, similar to what we're doing with GEO. GEO phase A is next year, 21. The LEO phase A is probably the next year. But again, we're looking to have a pilot launch as early as 2025. So, certainly no later than 2026. So we'll be doing a lot of engineering work, a lot of studies. We'll award additional, more detailed study contracts as part of phase A than what we did. It'd be more than just a 6-month quick study that we did with the BAAs, but more involved, more detail, and, giving a little more detail on the answers and the actual analysis that's required. So that'll happen, and that'll be open to anybody who, it'll be a competitive process, open to the community to propose to.
Yeah, let me add to that. It's probably worth noting that we're changing many of the paradigms of how we operate in aerospace, but not the design, the study phase, and then the early development phase, as NASA would call a phase A, and then a design and development phase for phase B, C, D. So we still have those phases of activities, and right now the BAAs that Vanessa referred to are scoping down the range of options that we want to consider for more detailed studies. None of the work that we've done to date precludes additional ideas or additional participants for joining later on in the next phases of the study. So we're at the beginning of the major development definition for GEO, and we're about a year later than that for the low Earth orbit constellation. And space weather is about a year as well. So there's a lot more of the investment. This is the scoping phase as we get to the actual detailed design study phases, which will be open to anybody with a good idea and the right assets to bring to the table.
Great. Vanessa, I also wanted to ask you about commercial weather data. Earlier this month, you released a solicitation to start buying radio occultation data, as you mentioned. What made you do that? And are you considering buying other types of commercial weather data?
Yeah, so let me say that absolutely. As I mentioned, our architecture that we did and looked at in SOSA is a hybrid architecture. And part of that architecture is the ability to purchase commercial data where it's available and where we've been able to show that it will meet NOAA's requirements and needs and mission needs. And so we started this process with a series of commercial weather data pilots over the last 3 years, I believe. We actually did 2 rounds. And we were looking at radial occultation data, which provides another way of getting vertical soundings, temperature and humidity profiles of the atmosphere. We looked at RO because there were several companies that were investing in that and planning to fly small satellite missions with RO sensors on board. So the opportunity was there. During the pilot phase, we bought data from them, and we looked at it and we tested it, and we looked at how we would bring that in, and we looked at, put it in our test models to see the impact of this data and the models themselves. And what we were able to demonstrate, and there's a report out, you can find the report on the web, for the pilot phase 2 was in fact, yes, radial occultation data was mature, it was ready to go, it could be used in NOAA models, NOAA mission operations immediately. So we've started the process of going out to actually purchase operational data. So as opposed to test data, we're actually going to purchase an operational data stream. And that RFP is on the street now. We expect to award contracts. These are indefinite delivery, indefinite quantity contracts in mid-November, with data delivery to start on December 1st. And again, it'll be, a small amount of data at first, just again to test the operational flow of how we bring that data into our operational models and our operational processing streams, all the systems that have to talk to each other and move the data around. And then we'll have a more involved purchase of RO data to follow under what we're calling delivery orders. So then the question is, what do we do after this? So this is obviously this particular RFP is for RO data because that was what we've been able to pilot and show was ready for prime time, maybe is the right term. But we're going to do another request for information next month. So in September, we'll be issuing an RFI that hopefully get it out on time. And we'll be going back to industry and asking, what is on your drawing board? What are you planning? What are your business plans are for collecting and acquiring environmental data, both in Earth environmental data, space weather data, all the different data that NOAA, the types of data that NOAA uses from space-based platforms, and see what their plans are. And then based on what we get from this market research, we'll decide if we want to do another round of pilots with different data types, obviously than RO, to go look at bringing in other data types. And so and I will say that the criteria for proposing or providing information is wide open. We're not, we're looking at all the different themes that we currently support with our satellite data and being able to provide satellite data in response to those thematic areas. So that'll be, and like I said, it'll go out in September.
Got it. One of the viewers asks whether the operational ingest system will be able to rapidly ingest commercial satellite data.
So I'll give a short one, and then Vanessa, you can add if you need to. Yeah, our secure ingest, our operational ingest system is designed to ingest any non-NOAA data, commercial, government, other agency partners, etc. So there's the version we use is there's trusted and untrusted in the sort of the security parlance, and if you don't know the full value, the custody chain of the data set, like it's not a NOAA satellite, it's considered untrusted. We bring all data in through that operational secure ingest, including our commercial data. Vanessa, do you want to add anything to that?
Yeah, I will say as we got ready to go operational with that system went operational a few months back. We did extensive testing on not only what we could ingest, that we knew we had, Himori 8 we talked about, obviously the commercial data will be coming in, we use data from the pilots, but we also, of course, looked at scalability. So because it's a cloud-based system and it's using cloud-based services, it is ultimately very scalable, and we tested our ability to scale up to, again, to handle a higher volume, higher workload than what we currently have. So yes, we're confident we can handle the load that we expect. And if not, we can scale it up even higher if need be.
Great. So here's a comment that I just want to read. It's that operational users balance many risks in continually providing services. Low latency and appropriate cadence of forecasting content are clearly important, but so is forecasting confidence. This is frequently overlooked and underexposed data variable, highly relevant for operational execution determination. So is there a confidence level? I just think this brings up the whole question of balancing the risk of this new model. People were used to the old model. Big satellites, long time, high confidence. Do you have to balance risk now in a new way?
So the question is very good in that it identifies that the issue of a well-performing system is more than just the quality of the observations. It's the end-to-end chain that is necessary and to be assessed and understood, and the confidence studies and the confidence analyses of new data. You add a new observation, which is whether it's a new, more of the same, like more RO, or a different measurement, like we put 3D winds LiDAR into an NWP, it can disrupt the stability of the model and the confidence in the output. So extensive testing is required, is the historical place, has been long-term testing of new data sets as we bring into the models. And that, just as I talked earlier on about our desire to change the tempo of infusion and direct development of new measurements, on the modeling side, there's a similar pressure to accelerate the ingestion and assimilation of new data sets, including understanding the confidence level you have in the new observations. So as part of our planning here, we're working very closely with our Oceanic and Atmospheric Research Group, the OAR, that does a lot of the model development, and particularly with NWS, who and NCEP and the different groups there that do the NWP, the numerical weather prediction modeling assessments, and the confidence to set calculations and measurements. So that we have, in parallel with the turn on, if you will, of the operational spigot to bring data in, we have to do advanced studies and assessments, as I think Vanessa was talking about, trial data against the models to do simulations and assessments to see, will this add or subtract from the confidence of the quality of the product, of the forecast product. So it is not overlooked, but it is a significant, I wouldn't say impediment, it's a significant responsibility and burden to bring these data on in a way that is improving the models. And that's part of why it has taken a while to upgrade models over time. We have lots of examples. ECMWF, the European version of doing model forecasting, is a friendly competitor, if you will, on assimilation of new data sets and the like. And there's an ongoing, friendly competition between us on how we do our model updates and assimilation. And we're learning from each other, but it is a challenge, and it will, I think, eventually limit the number of new data sets we bring in on a regular basis, because we have to make sure that we're adding quality to the output and not just adding data to the input.
Yeah, and I would also add on the space side, particularly, how balancing risk is a real issue with our new architecture and our new planning. So, if you're looking like LEO orbit, if you have a large, complex, multi-instrument spacecraft and with lots of redundancy and things, you sort of have a high cost of risk at the satellite level or the mission level. As we go to smaller satellites with more satellites in orbit, more frequency, more revisit time. If we lose one or two of those satellites, which might be more probable, because again, we're not building it with the same reliability that we would have built the bigger satellite, but the gaps themselves may be more tolerable, and those gaps, satellite data gaps, will be much, hopefully much shorter, because the time to get another instrument into space or to replenish or mitigate that anomaly, that loss of a mission, is much shorter than having to build another big, very large satellite or try to speed something up. So it's balancing risk across a portfolio as opposed to having the risk balance or the risk done at the single satellite level. Obviously, if you lose a JPSS satellite, there's a huge impact, because you might lose, many hours and months of data or years of data. Whereas, you have the ability to respond more quickly, be more flexible, as we talked about in our architecture through this next approach.
What we're trying to develop here, to follow on to Vanessa, is a resilient system, which is tolerant of single point failure. So we don't have a single asset dropping out doesn't bring down the whole system. But what another I saw in the comments, questions here about the reliability of small satellites is less than of the larger satellites. And we are looking to build a system that can, replace assets more quickly. The challenge that we have to overcome and address at the same time is that those longer term satellites that last 20 years, they have well-characterized instruments with well-understood calibrations, and we know where they were born, and we've watched them throughout their life, so it's easy to project and anticipate how you would bring on another instrument just like it. If you have a mixture of satellite observations providing an information content, they might have a different calibration curve, a different, temporal, thermal variation on orbits, a lot of idiosyncrasies that you have to accommodate as well and understand. So the challenge for us, and we've taken this by looking at how we actually produce products that try and filter out all of those idiosyncrasies so that the output product that goes into the user, whether it's NWP or weather forecast officer that's looking at the output, doesn't work, is blind or doesn't have to worry about all those variabilities. That puts a burden on us up front to do the pre-processing and the assimilation in a way that makes the output seamless. And it actually is a good dialogue between us and the providers of those instruments to understand which variabilities are more impactful and which aren't. So obviously you don't change the band or the spectrum response, but you might have a different type of detector which has the same band but a slightly different performance curve that we can take care of in software and make it seamless to the user. So assimilating new data sets and different reliabilities we see it as a systems issue, not just an instrument by instrument issue, and that's the way we're trying to address it, not just with hardware, but with the software side, with our ground systems, with machine learning and other approaches to come up with a common output with a variable input.
Mm-hmm. This question often comes up in these discussions. How does NOAA view the integration of commercial weather data buys, displacing the, how does this affect your partnerships with the academic community, with other government agencies that you share data with? Are there licensing challenges here?
So sure, yes. The short answer is yes, there are. When you buy commercial data, you buy it under well-defined terms and conditions, and the data rights and the subsequent usability of the data are a part of that terms and conditions. And we're actively looking at that, and we understand that historically, if it's a government asset, it's open because the people already paid for it, so it's free and open. And particularly with a commercial data purchase, a contract that we have out the RFP right now, we've defined sort of we ask the vendors to provide pricing for different data rights, and then it's a value judgment on the government, on the purchaser side, on our side. Do we buy it, under what terms we buy it? And part of that is not just the cost of the data, but it's the value of the data set. So RO data, for example, has applications for numerical weather prediction, and its shelf life is short. So there's a high value in the first 90 minutes, and then a day later, it's much lesser value. So we definitely see buying a lot of data with restrictions that may be cheaper is one option, but from a NOAA perspective as well, we balance that against the archival and the climatological data sets that we have and how we want to make these data available and interoperable with our community, our research community, and our operational partners. So I won't say that we have not determined exactly where that price point is, but that's a critical discussion on our point on the value of not just the immediate use, but the sustained use, the reuse, the long-term archives of the data sets. So we will be making those judgment calls based on feedback with the community on the prices that the vendors, and this is an open business model, we still don't know how it's going to turn out, on what the price, the impact of the observation at the price that we're asked to pay for it, and comparing against all other assets. So it is an open discussion, but there is definitely value, and we understand the different business models that can support a sustained operational commercial data set are changing the way that we work, and we have to think that through carefully. We are.
Here's a question from Dan Baker. It seems that NOAA's long-term data are increasingly important for scientific understanding of the Earth system, and NASA data are increasingly important for monitoring the whole Earth environment. How do you see the blurring of lines between the two agencies, and how do you coordinate multi-agency roles and missions?
That's a great question. The historical, and this has never been exactly the way, but it's been there's a lot of discussion about research to operations, R2O. When you have NASA on the research side and you have NOAA on the operational side, and there's this mental picture that NASA demonstrates something and then it gets transitioned magically over and NOAA then deploys it operationally for a generation. That's a model which doesn't really replicate itself in reality because of the timelines it takes to develop and everything else. But I think we are looking at it from a different way, looking at R2O and O2R, And I really look at it differently as research and operations. And the framing that we put together with our assimilation of all data available makes research observations just as useful for operational use if we can get it in fast enough and we're ready to use it. So I see a parallel, the model that we're developing here is a parallel system which uses research and operational assets equally if they're valuable and they have impact on the end product. Now, from a research perspective, we have our long-term data archives, which are part of NOAA's primary mission, which is to maintain the archive. And the climatological, the long-term data sets is just as important more important for some communities as the operational use of the data. So that's part of our objective to moving our archives and our sets to the cloud so that they're readily usable in real time with operational data as they come in. To the specific point about organizationally how NASA and NOAA are working together, I will say we have a very close coordination now working with NASA, and not just now, but historically, to see how we can make our archival data sets interoperable and interconnected. NASA's making their same migration of data and operations to the cloud, similar to what we are, and we have an ongoing and very active technical working group on how we do that in a similar fashion, so that the same metadata standards, the same search parameters can be used to look. You don't ask, I want to know what NASA's doing in ocean color. I want to know what ocean color data is available. You can pull up NASA, can pull up NOAA, can pull up Sentinel, Copernicus data, and all of these data can be used interoperably. And that's the intention, and that's the drive that we're pushing, working with NASA to make sure that our research and operational data are basically information that are readily usable by all users.
Here's a quick question on the BAAs. Is NESDIS planning to issue a new BAA for instrument mission and architecture concepts following the one issued in 2019?
Yes, we will. We certainly anticipate doing that. I'm not, and of course it's based on what resources we have and things, but we definitely want to look at, even with LEO Soundersat, we chose Sounders, and Soundersat is the first thing to look at because, as Steve mentioned, we knew we would be losing some of the legacy satellites in certain orbit periods, and we'd be losing that sounding data from those periods. So we looked at doing that first so we could get something up and look at multi-orbit, multi-temporal kind of impacts of, to avoid the gaps. But we know there's a lot of other things we need to measure from LEO. So we will do another series of mission concepts, instrument concepts for other things in the future. And we'll be working that planning out, probably in the first half of next year, trying to figure out what we do next. So, I'm not sure we'll have any BAAs going out in 21, but it certainly could be done near closer to the end of FY21 on looking at new things and other things. We'll also, of course, as we talked about, as we neck down the concepts that we looked at, even for the Soundersat, we got a lot of different ideas. We might want to do one or two additional, more detailed studies of the actual Soundersat approach, looking at key instruments or key concepts. And they probably wouldn't be a broad area agency announcement, but we would, again, be doing some studies that way. But yeah, we certainly plan to use this BAA process for the next many years as we look at how we do LEO missions, GEO missions, space weather missions, and how we do this early concept development, alternative development kind of work.
And just as a complement to the previous question related to the NASA and NOAA partnership here, we're also working closely with NASA. They do technology investments through their Earth Science Technology Office, ESTO, and through their Earth Venture mission calls. And we have worked with NASA to collaborate with them on both of those efforts so that as they do early technology development, we're looking as well and asking and co-investing with NASA in these to put up a NOAA operational utilization flavor on some of these calls, so that it's clear, not that there's anything wrong with just looking for the best science, but the best science also is the best operational science. So that there are other opportunities, and we're taking advantage of that by benefiting from NASA's investment in technology and their mechanisms, but also giving it a little bit of I call sort of a drift velocity or a bias towards an operational end use, so that we can. There are many ways to influence the technology, the next generation technology that NOAA might be using after these initial sounder measurements.
A few of the questions talk about the satellites that you're going to be losing, the weather satellites you're going to be losing in the near term like the POSE satellites, whether you've thought about refueling those or why you lose those.
So yes, we look very carefully at these assets and what are their lifetimes and what are the possibilities for refurbishment or life extension, I'll call it that. Not just at the satellite itself, but the satellite system that supports it, the ground systems, the operations, and the like. And so when you look at an on-orbit asset, you have to look at the whole value chain, is the satellite, the ground systems, et cetera. So these particular generations, the DMSP and POSE satellites, were all of the 90s generation. Most of those are not fueled, so there's not a question of refueling. They're battery powered and solar arrays, so they're aging, and we have limited opportunities for on-orbit servicing to extend their lives, and we have also cost. We have to look at the balance of cost for maintenance of the ground systems for continuing to operate these satellites roughly in perpetuity. And most of these are not. We can't deorbit these because they weren't designed in the period when we had controlled reentry. So the end of life is defined formally by a passivation, or in some cases, as you've seen with this generation, by battery failure. And we want to make sure that we don't have explosive battery failures in these satellites, because these are in popular orbits, and it's our good custodial job responsibility to make sure we don't have uncontrolled or damage from uncontrolled failures on the satellite. So as we look at these assets, we'll operate them. We're doing a cost-benefit analysis to extend the ground systems operations to the extent possible when it's value added, but then also to look at their health and status so that we passivate them when is the appropriate time at the right risk level for the satellite. So we know they will wear out. We're down to 3 on the NOAA side, NOAA 15, 18, and 19. I think it's 4 on the DMSP side. But just as I said, several of these have had battery failures over the last 10, 15 years, which are not ways we want to retire a satellite, by having a battery failure or something like that on orbit. So we have to manage the constellation and the orbit as much as we have to manage the individual asset.
We've come to the end of the hour, and we've got dozens of questions. I realize.
Great questions on here. I'm really impressed by I wish we had a chance to answer them all.
I do too. Perhaps we can get together and do this again, but is there anything that either one of you wanted to say as we conclude this?
I think the message, and looking at a lot of the questions here, is a lot of interest in about how we looking at a system. And I think that's the great way that the questions are coming across, is that the message that we have here is that it's not just, this may be space news, but it's not just the space part. It's not just the hardware in orbit that counts. It's really looking at the end-to-end value, whether it's the commercial section providing observations or the ground systems that are providing the data and analysis and dissemination that we're looking at. We're looking holistically at how we provide the entire value system to the nation, and I think there's multiple places where we are interacting with the community that are represented here on the line, but across, and I think we encourage and are open to ideas that influence and improve the value and the product that we produce, and no ideas are, not all the ideas are good ideas, but no ideas will be rejected out of hand. We want to hear what the best ideas are of our community, and look forward to opportunities to do that. Vanessa, do you want to add anything in the end?
Yeah, I was going to say something very similar. We really want to hear from everyone, get their best ideas. We are working on opportunities for exchange forum where we can talk and share ideas with you and you with us. Of course, we have conferences right now in the days of COVID. Conferences are online and things, but we still will. We plan to have a lot of people at the AMS conference as an example. We're working on some other community engagement forum that we can again tell you what we're doing, get your thoughts, get your ideas, and as I said, this is a hybrid architecture. This is not us deciding we're going to go do these things. We really want to. We really want it to be collaborative. We really want to involve industry and academia and everything in these decisions. And Steve talked about our sort of our joint venture program, which allows us to leverage technology with NASA. But we also expect to do something similar on the DoD side and as well as with industry side. So we'll be looking at opportunities where we can partner and collaborate on different different developments that it'll allow us to have more capability in the future.
Great. Well, thank you both for joining us. Brian, did you want to say anything as we close out?
I do. First, I want to thank both of our guests on behalf of Space News for, and not, I don't want to overlook the folks in NOAA Public Affairs who helped make this happen. And Debra, I want to thank you for doing another great job moderating a panel discussion. Thanks to everyone who submitted questions today and contributed to the conversation. I'm sorry we can't get to all of them, but they're great questions and our guests do see them. I also want to thank Maxar once again for sponsoring today's webinar. And finally, I want to thank all of you for joining us. A replay of today's webinar can be found at spacenews.com/segment/webinar. Can't remember that, just search Space News webinars, it'll come up. The poster replay should be up very shortly, I would say within an hour or so, maybe even faster than that. So that's it for today. From all of us here at Space News, we hope to see you back here again soon. Thank you.